Okay, coming to the next chapter is quadrilateral. What is quadrilateral? Simply, if you take a plane here, in a plane, if you take like A, B, C, D, these are non-collinear. Are not they are not collinear, means they are not come on a collinear means they are come on a single line. Cannot come these lines on a single line. They are non-collinear. If you join these segments, for example, if you take the non-collinear point, that is A, B, C, D, if you join them like this, they do not intersect except their end points. AB will going to not intercept AD except at end points. Then whatever the figure formed by these four lines is called quadrilateral. These A, B, C, D, they are called vertices. A, B, C, D are called vertices. Then what is AD? AD, AB and BC and CD are called sides. These things. Then whatever the AC and BD, they are called adjacent sides. Sorry, these AC and BD are diagonals, I can say. Diagonals, okay. Whatever, I will tell simply what are the adjacent sides. The two sides, I can say, is these AD and CD, they are called adjacent because they have a common point here. The two sides of a quadrilateral which have a common endpoint, see, which have a common endpoint. That's good. Then what are the opposite sides? These AD and BC are the opposite sides who do not have a common endpoints. That is called opposite sides. Okay, easily we can see with an example. We can see two sides of a do not have a common endpoints. That is called opposites. Adjacent side, adjacent angle. See, these are D and C are the adjacent angles which have a common arm. Therefore they are called adjacent. What are the opposite sides which are not adjacent? That is, which are not adjacent means angle B and D only, which are not adjacent angles are called opposite angles. Quickly we can take it. These are the about the quadrilaterals and definition and all those things. Next, coming to the some of the very interesting theorems. The sum of angles of a quadrilateral is 360 degree. If you take simply a quadrilateral ABCD, okay, draw diagonal BD. One of its diagonal, not two, draw one of its diagonal BD. See what happens. Then I will divide this angle D is 1 and 2 and B also 3 and 4. From the figure you can clearly understand this angle 1, angle 4, angle C is equal to 180 degree. Angle 2, angle 3, angle A is equal to 180 degree. From the figure you can easily understand. This add up it 1 and 2 equation, you can get 360 degree. Therefore, sum of angles of quadrilateral is 360 degree. The other theorem, second theorem is prove that sum of the interior angles of pentagon. See, pentagon, see, if we take A, B, C, D, E pentagon, I will join this. What we get? We get 4 triangles, 1, 2, 3, 4. This is 180, 180, this is 180. You add it, what we get? 540. We can do like this also. There is an alternative. we already proved in the first theorem this angle ABCD is a first quadrilateral. This angle sum is 360 plus this is 180. Okay, this is called 180. 360 plus 180, that is called 540. Here there are 4 sides we can get. See, n is equal to 4. What do we get? Triangles is 2. Okay, here n is equal to 5. We are going to get, here n is equal to 5. We are getting how many triangles? 1 2 3, that is 3 triangles. We observe the pattern here. Okay, easily we can prove sum of the interior angle is 540. Okay, the next, similarly we can prove the sum of all angles of hexagon. See, here n is equal to what? 6 here. Then we get triangles is 1 2 3 1 2 3 4 triangles we are getting. The sum is 4 into 180, that is 720. You can get it. Other words, we can usually use this formula from already hexagon plus 540 plus 180. 540 plus 180. Sorry, this is 1 2 3 4 1 2 3 4 5. Okay, yes, 720. You can also prove that like that. One thing we have observed clearly, that you have a n sides. I already told you in quadrilateral n is equal to 4. In quadrilateral n is equal to 4. Whatever the triangles we get 2. In pentagon n is equal to 5, we can get triangles 3. In hexagon sides is 6, you can get triangles 4. You directly we are multiplying 4 into 180. Here 3 into 180 in order to get 2 into 180. Therefore, there is a, we can cut up it to n minus 2 triangles. N minus 2 triangles. If n is equal to 4, you can get n minus 2 triangles. N is equal to 5, you can get n minus 2, that is n minus 2, that is 2, you can get 3 triangles. N is equal to 6, you can get n minus 2, that is 4 triangles. See, that is, you can just multiply into 180, you can get sum of all the interiors. So sum of all interior angles of polygon of n side is equal to n minus 2 into 180. This can be written as n minus 2 into n minus 2 into 90, that is 2n minus 4 into right angle. If there is a regular polygon of n sides, if you want to find out the if all the angles are equal, definitely if you divide by n, you can get each interior angles, that is 2n minus 4 divided by n. Means if there is a regular polygon, you can get all the angles are equal. Once there is all angles are equal, if you just divide by this, you can get by n, you can get each interior angle. This is the remark too. Okay, this is all about the things. Okay.